Welcome to the 11th hole of the Adventure Golf unit. Today we are going to be looking at the area of triangles, and I've actually copied some of the pictures from the previous hole where we were looking at the area of parallelograms, because if you look at the different parallelograms, all of these parallelograms can quickly be split into two triangles. So essentially, if you look at this, any one of these shapes, any one of these parallelograms, the area of the parallelogram, half of that would be the area of the triangle. So if I look at this first one, my base is 5, my altitude is 4, 5 times 4 would be 20. Half of that would be the area of this triangle, which would make this 10 inches squared. Here I have 3, altitude of 5, 15. My triangle, I have 2 of them in there, so each triangle would be half of it, 7.5 inches squared. I have 9 times 6, which is 54. Half of that would be 27 inches squared. And my triangle 7 with an altitude of 5, 35 would be 17.5 inches squared. So when I'm looking at the area of a triangle, a couple of different ways of looking at it is I can just take my base times my height and then multiply it by half, or I could take my base times height and divide it by 2. The thought process that goes on, the way I approach this, is I try to do this mentally. So if I look at base times height and I can find that and take half of that very quickly, that's essentially what both of these formulas are doing. A second way that I can do this, if taking half of this isn't as easy, the commutative property allows me to reorder multiplication, and it doesn't change the outcome of my problem. So I can essentially move these into any order I would like, and what that allows me to do is take half of any one of these numbers and multiply it by the other, and that would give me the area of the triangle. So initially I said 5 times 4 was 20, half of that is 10. I could look at this and say half of this is 2, 2 times 5 is 10. Down here, half of 6 is 3, 3 times 9 is 27. So I can take half of the product, or I can take half of one of these numbers and then multiply it by the other. That's how the commutative property works for me. Looking at these examples, here I can do 6 times 4 is 24, half of that is 12, or half of 4 is 2, 2 times 6 is 12. So my area here is 12 centimeters squared. 6 times 4, half of that, or I took half of 4 and multiplied it by 6. Either way, I got 12. My altitude here is 10. My base is 14. I can actually do 10 times 14, 140. Half of that is 70. I can do that easier than if I would say this is 5. 5 times 14 is 70. I know if 140 divided by 2, I can do more easily. Down at the bottom, we've got 30 as my base and 12 as my base. 12 times 8 is a little bit more difficult, so I can take half of either one of these. 6 times 8 is 48. So where I divide by 2 isn't necessarily important. Now you'll notice they put these angle lengths in here. Those were just to trick you. They had really no meaning for the area of this problem. 30 times 21. This one I'm actually going to write out. I'm going to take half of 30 right away and do 15 times 21, because I can do that mentally. 15, 30. Looks like the area here would be 315. Now, if I did 30 times 21, I would get 630, and then I would have to divide that by 2, which would give me 315. So I could do that either way. Again, here I mentally divided my 30 before I began. Here I actually calculated it out and then divided at the end. So the order in which I multiply by a half or divide by 2 isn't necessarily important. One thing you should notice when you're trying to find the area of the triangle, your base and height are always perpendicular. So perpendicular, perpendicular, here's a perpendicular, and then down here is perpendicular. Oftentimes they will throw in lengths that are unimportant just to throw you off. So this, they may say it's 12, and maybe this is 22. Those numbers would have no meaning. The only numbers that would have meaning are those who form a right angle. When you have a right triangle, your base and height are actually your two legs, because they do form a right angle. So this is an area where students often get confused, is they're not sure what the base and height are, but the base and height on a right triangle are the two legs that form the right angle. So here I can do 6 times 10 is 60 divided by 2 is 30. Or I'm going to look at this real quickly and just say 5 times 6 equals 30. Or I could even say 3 times 10 equals 30. So I can manipulate that equation any different way to find this area. This problem is a little bit different because they've split the base into two pieces, but I want to look at this as a whole. So my base is 10, my height is 10, divided by 2, 100 divided by 2 is 50. Or I could have just said 5 times 10 would have given me 50 as well, if I divided up front. Here I have to substitute in a length. This is 4. This is 2 times 4, which makes this height 8. So I'm going to say 4 times 8 is 32, divided by 2 equals 16. Or I'm going to actually, the way I would probably do this mentally would be to divide by 2 first. 8 divided by 2 is 4 times 4 equals 16. And this one's the only one with units, so those would be centimeters squared. This would just be units squared and units squared. Looking at the last 4 examples where numbers are actually given. In this case, I'm going to do the 28 and the 30 are meaningless because they do not form a perpendicular. So the numbers I'm actually going to be working with would be the 22 and the 26.8. I'm actually going to look at this from divide one of my lengths first, because it will help me actually, I think, do it more easily. 11 times 26.8. And I've got one number after the decimal up there, so I have one number after the decimal down here, 294.8 units squared. So again, instead of doing base times height divided by 2, I did base divided by 2 times height. I just changed the order, and that's the commutative property allows me to do that. Here I've got a base of 9, a height of 8. I'm going to split my 8 first. 8 divided by 2 is 4 times 9 allows me to see very quickly this is 36. So I could have done 9 times 8 is 72, divided by 2 equals 36. I think this is easier because I can do it mentally, much more easily than I can do 72 divided by 2. Here I've got 20 and 7, so I'm actually going to split my 20 and say 10 times 7 equals 70. And here I have a right angle, so my two legs that form the right angle are my base and height. I'm going to do 6 times 4 is 24, divided by 2 is 12. And I could have said 3 times 4 or 6 times 2. I could have split either number and then multiplied by the other number. Or I can split it at the end. Alright, when you're given grid paper, you can actually find area without any measurements given just by counting squares. Here I have a base of 4 and a height of 3, and I know that because they form a right angle. 4 times 3 would be 12, divided by 2 equals an area of 6 units squared. This triangle, although it's a different shape, still has a base of 4 and a height of 3, so it's still 12 divided by 2, which equals 6 units squared. In this case, my right angle base is 4, height is 3, 4 times 3 is 12, divided by 2 equals 6. So you can see 3 remarkably different shapes with an area of 6. I'm going to skip the green triangle for just a second and move down here to the yellow. And you'll notice the yellow is really the same triangle as the red. It's just been rotated 180 degrees about this point right here. And it's still 4 times 3 is 12 divided by 2 equals 6. If I look at this green triangle, my base and height are actually right here. And this becomes a much more challenging problem because these are actually longer than 1 unit. So an easier way of doing this problem is to use what I call the subtraction method. I look at the rectangle that fits around this triangle. And this rectangle is 1, 2, 3, 4, 5 by 3 units. So the rectangle is 15 square units. If I take out the stuff that's not being used, which is this triangle right here, which is 3 times 3 divided by 2, which is 9 divided by 2, which equals 4.5. And I take out this, which is 2 by 2, divided by 2. 2 times 2 is 4, divided by 2 is 2. And I take out this, which is 5 times 1, divided by 2. 5 times 1 is 5, divided by 2 is 2.5. So I have open space for 4.5, 5, 6, 7, 8, 9 squares.
Let's start off right by being at our team spots, ready to roll, prepared with our notebooks at 8 a.m. 10th grade will be in Kathy Berkland's room. 9th grade will be in the LLC. And McKinney will be in Jack Hagert's room. All right, thanks very much. Have a great day.
So I look at this, and my entire rectangle here is 15 square units. I took off 4.5, 5, 6, 7, 8, 9 units, and that left an area inside here that's colored green to be 6 square units. So when your base and height are more difficult to find, that's a different method. You're now ready to get online and print out the 11th hole scorecard.